Hello and welcome to NCC Group's Cryptopals guided tour. My name is Eli, I'll be your guide. In this video we're going to be looking at challenge 1 from set 1, which as you can see involves converting a string from hex to base64. So we have an input string that is hex encoded, and we're going to have to transcode that to base64 to get this output string here. That's going to be a two-step process. First, decoding from hex to raw bytes, then re-encoding those raw bytes as base64. In fact, all three strings are going to be raw bytes, as the Cryptopals rule here specifies. But the input and output strings obviously are going to be in constrained character sets that only use a subset of the possible values for a byte string. This is useful for pretty printing, among other reasons, as mentioned here, because it ensures that your input or output will not contain unprintable characters. So let's take a look at how we might do this. And we're going to create a little script for this challenge. I'm prefixing it with a 0 because these are going to go into the double digits and we want to be able to sort them by name. And we're going to take our input string and just put it in here as a bytes literal. We're not going to copy this in yet, but we'll get to that. So now, before I write the rest of this script, let me show you a couple options that we have here. So the first option that I'd like to mention would be if data hex was a normal encoded string, just a string literal like this, like so. This is class stir, indicating that it is not raw bytes, it is rather encoded. And so if we had this, we could use bytes.fromHex. This is a case insensitive conversion function that takes bytes as input and, takes hex as input and returns bytes as output. Now, this is good if we have a string as our input, but we're using bytes as our input, so we're going to have to find something else to use here. And what I would suggest using would be something from the standard library called base16decode. Bear in mind, of course, hexadecimal is just base16. And so it is interoperable with the canonical B16 encoding defined in some RFC, along with base64 and base32. And we can import B16 decode and take a look at how this would work. Now, out of the box, this actually is not going to work. And the reason why is because the canonical base16 encoding uses uppercase characters rather than lowercase. It is case sensitive. And so there's a couple of ways around this. We could cast this to uppercase, and then you can see that it works just fine. But there's also an option that we can pass, a flag here called casefold that specifies whether to be case sensitive or case insensitive. And if we pass casefold equals true, then we can see that it ignores the case sensitivity issue. So this is what we're going to use in our actual script. So let's go ahead and import that up here. And since we know we're going to be doing base64 encoding, I'm going to import that here as well. Data raw equals b16 decode, data hex, and make sure to pass casefold equals true, and then data b64 equals base b64 encode data. And I need to fix my import up here, as it's of course flagged that I'd written the wrong name. So now that we have these, we are actually ready to check our outputs. We have the core logic of our program all implemented here. So let's go ahead and print out these values. And if you're not familiar with what I'm using here, this is a format string that allows us to provide an expression and then print out first the expression, then an equal sign, and then the value that you get from evaluating that expression. So for example, you could do something like this, and then it prints out 2 plus 2 equals 4, naturally. Or you could do something like that, or you could just use it to dump the value of a variable, like so, data hex in this case. And so we're going to use that up here to dump all three of these variables. And let's see if this works as expected. And indeed it does. So that's very nice. There's a couple of changes we might want to make here. The first one is that the challenge hints to us that we're going to need to use this code for the rest of the exercises. What it means by that is that we're going to be working with bytes a lot, and so we want to know how to use them. This actual transcoding does not come up again as far as I can remember, although dealing with hex and base64 individually definitely does. However, in the spirit of the text of the challenge, if we wanted to take this logic and encapsulate it into a function that we could reuse, here's how we would do that. And I'm providing type signatures here to remind us that we're working with bytes and not strings here. And this is the exact same logic as we're using down here, as above, so below. And so we can just replace these intermediate states with this encapsulated expression. We get rid of data raw because we don't need it anymore. And now we are set except for one detail, which is that if we were to import the script, it would run all of this, including this logic and these print statements. And this would incur unnecessary compute, and these would pollute standard out. It would all be very confusing to whoever's importing this and doesn't want the output from some other challenge interleaved with their own output. And so it would be much better if we could prevent this from running on import, which it turns out is very easy to do with a name guard. Now, _name is something that's populated in every script. If you run the script directly, as we've done down here, then name will be equal to main, as we have it here. However, if you import the script, then name will have a different value that is related to the name that you're importing it under. So in this case, it would most likely be Cryptopals 01, which obviously is not equal to main, and so none of this would run, and the importing script would not have to deal with any of, the internal logic of this script, except for the internal logic of the definition that it imported. So it would be able to invoke these functions and not worry about anything else. So this is a nice way of encapsulating functionality that we're going to be using in pretty much all of these scripts. There's one other thing that we probably want to do here before we wrap this up, and that is make sure that our output is actually correct. We could go through it character by character. Personally, I'd rather not. So let's just do this instead. And now when we run the script again, we see that our little celebratory print statement is activated, and so we know that the conversion worked and that we've solved the challenge. Thank you for watching. I hope to see you in the next one.